Hello, my name is Jonas. This video is based on my master thesis, HDR and Colorist, which I wrote back in 2019. Here I'll present you with key concepts and terminology related to high dynamic range video. Amongst other things, I will talk about the 5 key parameters of digital imaging technology, color volume, and the SMPTE ST2084 standard. The video you're about to see was originally released on YouTube and had over 4,000 views and 100 likes before I made it exclusive for this course. So, put on your sunglasses, because it's HDR time. HDR, or High Dynamic Range Video, is a fairly new technology which only been around for a couple of years commercially. HDR video should not be confused with HDR photography, which is something totally different. To understand high dynamic range video better, I will go through the 5 key parameters of digital imaging technology, which is spatial resolution, temporal resolution, quantization, contrast, and color gamut. These 5 parameters can be divided into either having quantitative properties or qualitative properties, meaning either contributing to the amount of pixel in an image or the quality of the pixels. The quantitative properties are quite straightforward and easy to describe, and it's all about resolution, both spatial and temporal. Spatial resolution regards the amount of pixels in an image and is described by the amount of vertical and horizontal rows of pixels. For example, 1920 by 1080 for Full HD or 3840 by 2160 for UHD 4K. Temporal resolution refers to the frequency or refresh rate of a video signal, known as frames per seconds or FPS. In cinema, 24 FPS is very common and basically the standard, although we have seen examples of higher frame rates, for example with the 3D HFR versions of The Hobbit. Raising the spatial and temporal resolutions will simply put results in more pixels more often. Finally, when you see attributes such as 1080p30, it refers strictly to resolution, both spatial and temporal. If higher quantitative properties can be described as more pixels more often, then higher qualitative properties can be described as a larger volume of possible pixel brightness and color values with finer numerical gradation. Let's find out why. The finer numerical gradation part refers to quantization, which is the process of converting an analog signal into numerical values called samples. 8-bit quantization means that the signal is quantized to 2 to the 8th power, or 256 code values. In the world of RGB color, this means 256 code values of red, green, and blue, and together these 3 channels make up the entire color palette of 16.7 million colors in 8-bit. Even if 16.7 million colors intuitively might seem like a lot, it's actually quite limiting and can result in banding artifacts over areas with fine gradation, such as the sky. Since there are only 256 code values per channel in 8-bit, there's also only 256 code values between black and white, where all 3 channels are used in the same amount to create different shades of gray. To put this into perspective, 256 shades of gray in 8-bit can be compared to 1024 in 10-bit or 4096 in 12-bit. The contrast or dynamic range of a TV refers to its luminance, the minimum and maximum amount of brightness the display is able to produce. While luminance is measured in candela per square meter, also known as nits, the contrast is presented as a ratio between the darkest and the brightest level the display can produce, for example 1500 to 1. And the maximum amount of brightness in standard dynamic range, or SDR, is limited to 100 nits. Contrast dynamic range, or tonal range, is the parameter that directly relates to HDR, which raises the maximum brightness value several times, theoretically up to 10,000 nits with Dolby Vision. This added brightness allows for a much greater highlight differentiation and can result in a less flat image. Another possibility is to work with a variable black and white level, known as tonal ranging. Here you can create a temporal contrast when going from a bright scene to a dark scene, for example. In this case, the audience's eyes might have to adjust from the brightness to the darkness, creating extra tension to complement the story. Last of these 5 parameters is color gamut, or color space, which defines the reach or richness of hues. The CIA 1931 chromaticity diagram, also known as the color horseshoe, was created specifically to encompass all the colors the average human can see, and different color gamuts encompass various amounts of this diagram. The legacy color space BT709, also known as Rec 709, leaves a large set of visible colors that cannot be rendered, while wider color spaces such as DCI-P3 or Rec 2020 is able to render more of these visible colors. Related to color gamut is the concept of color volume, which is a fairly new term within industry. Color volume regards both high dynamic range and wider color gamuts, which are becoming linked within different standards. There are some misconceptions regarding color volume, where a statement can be that the combination of high dynamic range and wider color spaces can result in things like a bright blue sky. And this relates primarily to high dynamic range and not its combination with wider color gamuts. If you want full 100 nits of brightness in SDR, then you won't have any color, since all 3 RGB channels are used at the maximum value, resulting in white. And this is because the RGB system is additive. HDR raises the maximum brightness level, meaning that you now can have things like a bright blue sky or bright yellow fire. So, color volume is a concept relevant to visualize the brightness range of available hues, and is related both to high dynamic range, which expands on the limitations of SDR, and also a wider color gamut, which expands on the hues that's available. Before starting to work in HDR, it's important to get familiar with the SMPTE ST2084 standard, which ratifies the perceptual quantizer electro-optical transfer function, also known as the PQ curve, created by Dolby. The PQ curve allows for maximum brightness of 10,000 nits and requires a signal with a bit depth of at least 10 bits. The perceptual quantizer was developed in relationship to how the human visual system interprets the world, which it does in a non-linear fashion. As an example, in a room lit by 50 candles, the amount of change of doubling the amount of candles to 100 is seen as an equally large step as removing half of the candles to 25, therefore making the human visual system more sensitive to low light. In PQ HDR, half of the code values are used in the 100 nit range, meaning that 10-bit HDR double the amounts of code values in the SDR range compared to traditional 8-bit video. Another important difference between a regular gamma curve in SDR and the perceptual quantizer is their relative versus absolute nature. In traditional SDR, the actual output brightness of a code value is dependent on the display and its settings, while in PQ HDR, a code value refers to specific brightness output of the display. There's a lot more to be said about this approach and the problems with it, and how Dolby Vision and HDR10 and HDR10 Plus tries to solve those by using static and dynamic metadata. But that's a topic for another time. Be sure to also check out the notes for this video, since it is a lot of information to take in and digest at once. In the next section, I'll present you with a low-cost solution for those of you who wish to get started with learning and creating high dynamic range video, using a C9 or CX series OLED from LG and the popular color grading and video editing software DaVinci Resolve. See you in section 2.